Industry, mining, and commerce have made Lake Erie one of the busiest bodies of water for ship traffic in the world. Lake Erie has a steady flow of ocean-going vessels between the industrial centers of Canada and the United States and the St. Lawrence Seaway. In the past, the steady flush of contaminants from lakeside industries, as well as raw sewage from shoreline communities and pollutants from ship traffic, had turned Lake Erie into a toxic cesspool. Lake Erie is the most southern of the Great Lakes. It is practically cut in half by the Canada-United States border. For more than 2 centuries, Lake Erie has claimed shipwrecks by the hundreds. One of them lies near Port Dover, off a narrow jut of land called Long Point. This shipwreck has brought a team of documentary filmmakers and shipwreck hunters to Lake Erie. They have come to Long Point to help document a scientific investigation into the marine biology and geology associated with this shipwreck. With the team for this expedition are 3 members of the Port Dover chapter of the organization Save Our Shipwrecks. They include James Murphy, Darren Keyes, a side-scan sonar technician, and Gordon Haddon, current president of SOS. This first dive is to a coal steamer which sank in 1908. The team will evaluate the marine life on the wreck and measure the rate of sedimentation on the site. They'll also take samples of mussels from this wreck in shallow water in order to compare it with mussel samples which the team will later take from a wreck in much deeper water. Lois T is an excellent platform for diving. A shipwreck is a time marker for scientists. The date of its sinking provides a means for measuring change on the lake bed over periods of time. A shipwreck also provides a control site for scientific research, a fixed point to which they can return and make comparisons. Yet for all the science associated with diving a shipwreck, there is always the wonder and fascination at seeing a wreck appear through the shadowy murk of the lake bottom. This is the coal steamer Pratt, which had caught fire while steaming past Long Point and was beached at Gravelly Bay, about 3 kilometers from the lighthouse. It's like a broken body on the bottom, bones sticking out from the mud. What Chris, a marine biologist, notices about this wreck is the lack of marine life. A shipwreck most often becomes an artificial reef teeming with life. But this wreck seems to provide sanctuary for only 2 species: zebra mussels and lake perch. The mussels feed on algae, and the lake perch feed on the mussels. A 10-year environmental program has cleaned up much of the industrial pollution in Lake Erie. Marine life should be thriving. Has the ecological balance of the lake been disturbed by something other than industrial contaminants? Is this foreign species of mussel threatening marine life in this great lake? The divers surface with their samples. Chris is anxious to compare these shallow water mussels with the deep water samples the team of scientists will take from another shipwreck which lies in 55 meters of water. The Canadian Navy's research vessel, HMCS Cormorant, is the base of operations during these scientific investigations on the deep water wreck.
SDL is submerged.
The scientists believe the shipwreck could help them answer some intriguing questions about the spread of contaminants in Lake Erie and about the attack on the lake's ecosystem by a foreign species of mussel. John Davis, the team's researcher, joins the scientists aboard Cormorant. John will direct the team's effort to document the science. The scientists include Steve Blasco, a marine geologist with the Canadian Geologic Service. Steve is trying to understand how sediments and thus contaminants are moved in the area for purposes of environmental planning and pollution assessment. Steve conducted similar geological research on the Titanic. Donna Graham is a marine biologist with Fisheries and Oceans Canada. Donna is using the shipwreck to learn more about the distribution rate and ecological effect of a foreign species of mussel which has invaded Lake Erie. Because these scientists now know this shipwreck went to the bottom between 1872 and 1874, they can use the wreck as a time marker for measuring long-term changes on the lake bed. The scientific team will conduct their investigation from the decks of the Cormorant and from inside her deep-diving SDL submersible. SDL is equipped with a remote control arm for sample taking and with video cameras and recorders for documenting what the scientists see on the bottom. SDL stands for Submersible Diver Lockout. SDL is an ocean floor observation platform. It can carry up to 5 crew and submerge to a maximum depth of 2,000 feet. Lake Erie is one of the busiest bodies of water for ship traffic in the world. It was once the most polluted. Over the past 20 years, environmental efforts have cleaned up and revived this great lake. Now there's a new problem threatening Lake Erie: quagga mussels. SDL allows researchers to see ocean bottom and lake bed up close, rather than relying on making an educated guess from the surface. SDL makes their marine science more precise and more controlled. This submersible is principally used for geological, biological, oceanographic, and archaeological research. This is Donna's first descent in SDL. Her first up-close look at the mystery wreck. She has a window seat for what is about to be a fascinating underwater experience.
surface control, SDL, UQC check, over.
This is surface control. Do you have SDL on communications? 10, over.
Surface control, this is SDL, roger.
Descent in SDL is slow and measured. Expectation is high. Visibility is still somewhat cloudy, but it will clear as they descend deeper and deeper. Eyes strain to see beyond the reflection of SDL's lights off particles in the water. For SDL, 55 meters is a shallow dive. What makes this dive so interesting to the crew is that they are diving to a shipwreck from the 1870s.
This is surface control. Are you on the wreck? Over.
It's like trying to see through thick fog, which seems to clear, revealing an unbelievable shipwreck.
Surface control, SDL. We are on the wreck, over.
This is surface control. Roger.
Zebra mussels have encrusted the wreck almost entirely. It's like looking at a ship in a bottle, flecked with gold. Cold, fresh water of Lake Erie has helped keep this wreck in such a remarkable state of preservation. The wreck almost seems to be sailing in a fog bank, pitched with the wind, its bowsprit cutting through the mist. It's not hard to let the imagination run free, if only for a moment, to see this ship as it once was, plying the Great Lakes trade, perhaps sailing between Cleveland and Buffalo, running the canals into Lake Ontario and the St. Lawrence Seaway. First order of business for this dive is to take documentary footage of the wreck, particularly of the bow and stern sections. The wreck is well preserved. It's remarkable. This is the first time these scientists have seen this two-masted schooner sitting upright on the bottom. The masts are still in place, and some rigging is still attached. For the first time, Donna gets a true picture of mussel behavior in their natural environment. This is invaluable for her research. She can now see their orientation on the bottom, their positioning, their movement, their feeding mechanism.
See on the sign here, mussels along the bottom, They have their siphons out. See, it almost looks like a tube coming out of the mussel. Yes.
The mussels are filter feeders. There are two species of them. The first, the zebra mussel, invaded Lake Erie in 1986. It inhabits rocky areas to a depth of 30 meters and must stand upright in order to feed. The second species, the quagga mussel, was first noticed in 1989. Because it feeds both upright and lying flat, the quagga mussel can inhabit almost any kind of lake bottom. They have even been found at depths of over 130 meters. Both species originate in the Black and Caspian Sea region of Eastern Europe. Together, the zebra and quagga mussels filter algae from the entire basin once every several days. Water clarity has improved in the past 10 years, with transparency increasing up to 85%. However, there is a problem. Plankton feed on algae, and fish feed on plankton. Less algae in the lake means an ever-decreasing food supply for fish. The zebra and quagga mussels have upset the ecological balance of Lake Erie and the other Great Lakes. Donna Graham wants to know how, why, and what can be done about it.
What, 15 off the bottom? 5 feet off the bottom?
The scientists take samples from the silty bottom, as well as samples from the water column 6 inches above the mussel bed. They also measure sedimentation depths around the wreck for Steve Blasco. Sediment has been building up on and around this wreck since the day of its sinking. Determining the amount of sedimentation, where it occurred around the wreck, and how long it took to build up to this depth could tell Steve Blasco a lot about bottom currents and their direction. Understanding the biology and geology of Lake Erie requires an accurate knowledge of how the lake works, of the dynamics of its currents and their interaction with the coastline and sediments on the bottom. With the shipwreck as a time marker, Steve hopes to get a more accurate picture of the long-term dynamics of the lake. The last objective for this dive is to set a metal frame in place in order to conduct a mussel count for a square meter of lake bed. Samples have been taken, photographs and videotape recorded. Now it will take several months of analysis and computer modeling before the scientists can come up to any hard and fast conclusions.
Roger, thank you.
Nevertheless, this series of dives has been a success. Donna Graham had already seen something she had not expected to see. The number of mussels at that depth is surprising. Their distribution is dense. There are sheer volumes of them. For Donna, the dive has already proven its worth. This dive has also had a significant impact on Steve's research as well.
The interesting part of it is that the wreck shows us indication of strong current action in the bottom of the lake in areas where we thought current action was very limited. And so over a 150-year period, this wreck has accumulated evidence of current activity. The currents are strong, and they are in fact in the opposite direction to which we had modeled or predicted.
The information gathered from this dive will help Steve, Donna, and their associates draw more accurate conclusions about erosion and the spread of contaminants in Lake Erie, and about the growth and distribution of zebra mussels in the lake. They'll be able to offer more accurate advice on how to remediate the problems which already exist in the lake, and design a procedure and methods for avoiding ecological disaster in the future. The effort of the Canadian Navy and the scientific community for identifying and dating this wreck and then using it as a time marker for their scientific research has been a model of cooperation. For this team of divers and scientists, the opportunity to dive such a magnificent shipwreck and to search its decks and hull as part of a scientific investigation has been an experience the rest of us only dream about.